Right, how do I determine if an angle is acute, obtuse or reflex? Now, one thing you got to remember, acute angles, let's write this down over here, acute, the angles are less than 90 degrees. That symbol there means less than. Right, next we have obtuse angles. Obtuse angles are bigger than 90 degrees but less than 180 degrees. That's obtuse. And reflex angles, obviously bigger than 180 degrees but less than 360 degrees. Right, that's something you need to remember. Right, as an illustration, I'm just going to test one of these angles to see if it's acute or obtuse. The one I will test is over here, that one. Right, so if you can see that automatically if it's acute or obtuse, but I will show you if you're not sure. Right here, got a cardboard, and I know the corner of a cardboard is 90 degrees. It's how it's made. So that's 90 degrees, that corner is 90 degrees. Now, all of that is 90 degrees as I've just said. But remember, I just want to measure this angle over here, just that bit there, that corner. So if I start moving this pencil, now it automatically becomes acute, it's less than 90 degrees. So that angle there is acute, less than 90 degrees. If I take it back, right, these two pencils make 90 degrees. If I start moving the pencil inwards towards the other pencil, it automatically becomes acute. Right, so remember, this angle is acute. Right, looking at this angle over here, put a mark there. Right, it's hard to tell if that is a right angle, maybe acute, obtuse. Well, we need to test it out. So what I'll do, get my cardboard, those two pencils make 90 degrees. The angle between those two pencils is 90 degrees. So now if I move my pencil to match up with the side of the triangle, obviously that's more than 90 degrees. Remember that those two pencils, at the moment it's 90 degrees, but as soon as I move the pencil away from the other pencil, away from it, it automatically becomes obtuse. That's obtuse, obtuse, obtuse. That's obtuse. So that angle there is obtuse. These are different types of triangles that are managed to fit inside a rectangle. I'm going to describe each and every one of these triangles. Starting off with this one here, you've got this equilateral and it's acute. It's equilateral because this side, this one and this one, all three are the same size. And it's acute because all these angles here, this one over here and one over here, these are all less than 90 degrees. That's why it's acute. It's an equilateral acute triangle. Let's have a look at another one now. Let's have a look at this one, Scalene and obtuse. It's scaling because all three sides, right, just this one and this are all of different sizes. That's why it's scaling. So when all three sides are different sizes, it's a scaling. And the reason why we call it obtuse, because one of these angles is more than 90 degrees. Is this one over here? Right, this one is more than 90 degrees. That's why we call it obtuse. Scaling obtuse. Right, let's try another one. Let's go for this one. This one here, we have an isosceles obtuse triangle. It's isosceles because two of the sides are matching. So this side, all of that, matches all of this side. And we can indicate that by putting these marks. So these two sides are the same. That's why it's an isosceles triangle. And the reason why we call it an obtuse triangle is because one of these angles is more than 90 degrees. This is less than 90, it's right here. That is more than 90. That's why we call it obtuse, isosceles obtuse. Right, let's go for this one over here. It's also isosceles because two of the sides are the same size. It's this one over here, put a mark here just to indicate it. And this side are the same size, just put a mark there. And the reason why it's acute, because all three angles, there's not a single angle that's an obtuse, that's more than 90 degrees. Every single one of those is less than 90. That's why we call it acute. Isosceles acute. Right, this one over here, I'm going to call this one a scalene triangle. All three sides are different. Kind of looks the same. These two sides kind of look the same, but they are different, slightly different. All three sides are different, and it's acute because all three angles are less than 90 degrees. Right, this one over here, it's a scaling because all three sides are different sizes, and it's a right angle because this corner over here, as you can see here, this one over here is 90 degrees. Right, last one over here, it's also a right angle triangle because of this over here. That's a right angle, and call it isosceles because this side over here, all of that, is the same size as all of this. And we put a mark to say, yeah, these two sides are the same size. So it's an isosceles right angle.